I spent a number of years working in the WordPress agency space, and quite often we would get concerns from clients about their website performance. They would run lighthouse audits and then see some, lower than expected scores, scores that didn't match up with their performance standards for the website. They would then come to our agency and say, "Hey, can you, make it faster? Just improve the site, the page speed." So my team and I would look into it, and we would maybe fix some things in their custom code that they owned to improve scores. But often the culprit was third-party scripts, right? We would come back to the client and say, well, yeah, we looked into the issue and we made some optimizations, but really it's the, interactive chat widget you're loading in, it's your analytics platform, it's your other behavioral analytics platform, it's your advertisements platform, all of those third-party pieces of code that we don't control, but we're loading in. It has to be downloaded, parsed, executed, all of that on the browser. That's just taking up resources and causing your speeds to be slower, right? So the client would hear that and say something like, "Oh, well, we have to have those, but can you just make it faster anyway?" Right? And this is the tension that often exists in web development, where we have these important third-party scripts that really are legitimately needed. However, it comes at a cost to performance. Thankfully, a new piece of technology has emerged within the last few years called PartyTown. It allows you to offload some of those third-party scripts from what's called the main thread, which is what the browser uses to do all of the rendering that it does. And instead of it doing all the work, you can offload the work of these third-party scripts to a web worker. So it runs in a separate thread. And because this work is able to be done in parallel and it frees up the main thread, it results in overall better performance. So you can kind of have your cake and eat it too, in the sense that you still get to use all those third-party scripts, that are important for the site, but not, block rendering or do detrimental things to the site as well, and still have great lighthouse scores and speedy performance. In this video, we'll talk about the performance problems that third-party scripts can cause. We'll talk about what PartyTown is and how you can use it to alleviate those problems. And after that, we'll dive into a code demo. I'll show you a Next.js application that has pretty low lighthouse scores caused by some heavy third-party scripts. And then I will enable PartyTown, and then we'll run our lighthouse audits again and see just a drastic improvement on that site's performance. And then finally, I'll walk you through how you can enable and use PartyTown in your own Next.js applications. And just a note for anybody watching who maybe doesn't use Next.js, use a different web framework of some kind, this video should still be useful to you just for understanding the root problem and then what PartyTown is and how it can be used. And on the PartyTown website, they even have integration guides for a number of popular frameworks. So for the last section of the video, you can just kind of refer there instead for the implementation steps. So with that, let's dive into it. First, let's take a minute to better understand the problems that third-party scripts can cause. To do that, I'm going to reference a few sections of this article here that I wrote on this same topic. Specifically, I want to scroll down to the Understanding the Problem main thread overload section here. So this says, in modern web applications, the browser's main thread is where critical tasks like rendering, user interaction, and layout updates occur. But third-party scripts often hog this thread, leading to sluggish performance. Chrome's Lighthouse documentation breaks down how script execution dominates the main thread, especially from third-party code. This article is linked in the description of this video. If you want to read the Chrome docs here or revisit any of the other links while we're going through this. So to continue here, these scripts, third-party scripts, can block rendering, cause input delay, and significantly impact metrics like first input delay and time to interactive. So block rendering, this refers to rendering the contents of the HTML page itself. So you can imagine a user, maybe visits your page and then half the page loads or a portion of it loads, and then all of a sudden the browser stops rendering the page because it's working hard processing some third-party scripts. and then it gets back, gets caught back up and renders the rest of the page, right? That's a poor user experience because to the user, they just, saw it just looked like kind of a pause in the action, right? Instead of the browser continuing to render the page, it just seemingly got hung up, right? There's some extra lag there. That's a poor UX. Also, input delay, the next one on the list here, that refers to if the user takes an action, like clicks a link, clicks a button, does something, there's a delay there before the browser is able to respond to that user interaction. So there again, that can cause the web page to appear, sluggish and have performance problems as well. So both of those, you'll see if you run like a Lighthouse audit in Chrome, for example, you would see the first input delay and time to interactive impacted if third-party scripts are causing issues there. Getting back to the article, it says, while some optimization techniques help, like adding async or defer attributes to the script tags, or using tools like Next third parties, which we'll talk about in a moment, those are often not enough, right? So what do you do? Again, back to my story about my agency clients I worked with, if they say, oh no, we have to have these third-party scripts, but just make the site faster anyway, right? And you don't control that third-party code, so what do you do, right? So one solution is PartyTown, as we'll discuss here. So let's dive into what PartyTown is. So PartyTown is an open source library from the folks over at builder.io that offloads third-party scripts to a web worker, freeing up the main thread. This means your app's critical work, like rendering the UI and responding to user input, can continue smoothly while third-party scripts run in isolation. And just a disclaimer here, PartyTown is currently in beta and being actively developed. While it doesn't support every use case yet, it provides a powerful way to boost site performance. All right. And just a fun little, exploration side quest I went on here. Why is it even called PartyTown? That's a wild name, right? Where did they come up with this? So here's what my digging, came up. Here's what I came up with here. So the name PartyTown is a playful metaphor. The main thread equals your app's downtown, so to speak, where essential work happens. Third-party scripts are like the noisy neighbors cluttering up your downtown. So PartyTown then moves those noisy neighbors out to the suburbs, a separate part of town, so they can party without disturbing downtown's flow, right? So in technical terms, they're offloaded to a web worker. So it's kind of a fun background on the naming here. Before we go any further as well, I just want to point out the PartyTown site. So if you go to their own website, partytown.quick.dev here, you can see this page kind of opens with some of the same things we've been talking about in this video, discussing the issues with just overloading the main thread with all these third-party scripts, and then it positions PartyTown as the solution to that, right? This graphic here is particularly helpful. So you can see that, the blue dots here represent your custom code of your application that's rendering. And then the orange dots represent third-party scripts. So you can see with this image on the left, there's just a single thread, the main thread of the browser that's just trying to do everything, right? Your app's custom code, all the third-party code. And you can see that some of the dots get in the way of other dots or might, block the browser's ability to load the rest of your custom code. After PartyTown is implemented, though, your application ends up looking more like this graphic on the right here, where the blue dots, your custom code, can just continue being rendered unencumbered, by third-party scripts, and then you have a completely separate part of town, so to speak. You have a separate thread in the browser that's just focusing on rendering the third-party scripts. All right. So both can execute and do the work that they need to do in parallel. So this makes everything faster. One thing that's helpful to just keep in mind here is the same amount of work is being done either way, right? Whether you ask the main thread to do all of this work, it still has to process your same exact, custom application code, and all of the same exact third-party code has to be downloaded, parsed, executed, and so on. And then, with PartyTown implemented, all of the same work still happens. However, because you're offloading some of it to a separate process, you're able to do that work in a more efficient way. So this is really appealing, to me and to many others who have adopted PartyTown to help with performance issues. So with that all said, let's talk about when you should dive in to considering, implementing PartyTown. Is it just always worth it, like every website first thing you do, or should you, maybe take some other best practices first and then reach for it? So that leads us to the next section in this article here, before you reach for PartyTown. So before integrating PartyTown, consider these best practices. So add async or defer attributes to third-party script tags so that they don't block rendering. There's a link here if you want to learn more about those. Use the Next third parties package for smarter loading in Next.js. This is an NPM package, but as of the time of this recording, it's still experimental. So maybe look into that in the future when it's no longer experimental. Next, follow the performance tips on web.dev to minimize script impact. And then for Next.js projects, Next.js has its own script component with a strategy prop that you can set, to a few different things. So there's if you want the script to load before the page is interactive, after it's interactive, lazy load it, and they even have a worker strategy here. So let me show you what I'm referring to. So here's the Next documentation on the script component, right? So you can see it imports script from Next script and then uses it like this. So it renders that component and then gives it the source, but it has a strategy prop that we just referred to that looks like that's right here, right? So strategy, you can set any of these options, and there's even a worker option here. This is experimental, as you can see, and it loads in a web worker. That sounds familiar, right? Sounds like what PartyTown does. And in fact, this strategy uses PartyTown under the hood. That's how it works. However, there's a caveat here. As of the date of this recording, the worker strategy only works with the Next.js pages router, right? Not with the newer app router. So if you have a modern Next app using the app router, worker won't work. That sentence sounded funny, but the worker strategy won't work in that case. Maybe in the future it'll be added, but for now, it doesn't work. But never fear, I'll show you when we get to the code demo portion of this video, how to get PartyTown up and running in an app router application without using this, the Next.js script component in this same way. We're going to see how we can implement it a different way. All right, so back to this list of things to do before you reach for PartyTown. If you've gotten through all of this list and you've optimized your scripts as much as possible, then I would recommend running a Lighthouse audit to test the site's performance, paying particular attention to the minimize main thread work and reduce the impact of third-party code sections of the report. Then, if you find that third-party scripts are still an appreciable performance issue, at that point, consider using PartyTown to offload them from the main thread to web workers. All right, so with that, next we'll dive into our coding demo. We'll look at the Next.js application with poor performance and see how we can improve that using PartyTown. The demo application we'll look at is available on my GitHub here, and I'll include a link to this repo in the description of this video as well. So if you want, you can clone this down to your machine, run npm install, and then npm run dev, and follow along with some of the things that I'll demo next. You can see that I have cloned down the project here on my local machine, and I have it running as well at localhost 3001, right? So this is just a basic Next.js site, and it loads 4 slow third-party scripts in its layout component. So let me show you that. So I've cloned down the code base here, and you can see in layout.tsx, we have the root layout component. And then inside of here, you can see I'm importing the script component from Next script, and I'm loading 4 things. So the first one is just a generic slow script. So you can see I'm loading this through a JS deliver service to mimic a third-party script. Really, the code though is coming from this slow script JS file here. So this is what it does. You can see that it just sleeps basically for 300 milliseconds to simulate blocking JavaScript for that long. Likewise, in the next file, I'm just simulating an ad platform like Google AdSense, for example, injecting some ads into the page. Same thing. I'm delivering that through JS deliver service, but the code ultimately comes from this file right here, fake ads. So you can see what it's doing. I just have this immediately invoked function expression here, and it, similar to what we saw last time, it blocks the main thread for 300 milliseconds to simulate, running some heavy logic in JavaScript. It injects an iframe into the page, simulating an ad, being injected into the page, and it also simulates a slow loading ad image. So we have this image here, comes from Wikimedia, which is a 4 megabyte, large image being injected into the page. So some of the, same things that an ad platform would do are kind of, being simulated by this script here. And beyond those two kind of contrived examples of a slow script and an ad script, I have two real third-party scripts that we're using. So I have Google Tag Manager here. You can see I'm loading it straight from googletagmanager.com, as well as an intercom chat widget. An intercom, if you're not familiar, is a very popular, interactive chat widget used on a lot of websites. So that I'm loading from Intercom's website as well. So those four third-party scripts, we're going to go ahead and run an audit in Lighthouse to see where performance is, and see if we can improve it with PartyTown. So let's do that. I'll head over to the browser now, and I will pop open the Chrome DevTools. And here, let's first take a look at our Sources tab to see where work is being done. All right, so if you pop over to Sources, you can see top here. And top is the same thing as the browser's main thread. Those two are synonymous here. So you can see that top, the browser's main thread, is handling all of our application's custom code, rendering our app, but a bunch of other stuff as well, right? We have that giant image from Wikimedia. It's taking care of that. It's taking care of the intercom widget. Here's Google Tag Manager. So you can see that it's being overburdened, right? It's responsible for all the app rendering, but also all these third-party scripts without offloading any of that work anywhere else, okay? So let's see how this setup impacts performance. So to do that, I'll head over to the Lighthouse tab, and we'll kick off an audit to look at the performance. All right, so now that that audit is done, you can see we're scoring pretty darn low here. I got a performance score of 65 out of 100, right? So it's not too great performance there. So let's scroll down and see what the issues are. So right here, highlighted in red, we have total blocking time, almost 2.4 seconds, right? So if this were a production website, this would be very concerning for users having to wait for things almost 2.5 seconds, right? It's unacceptable. If we scroll down to the diagnostics list here, we can see the reasons why. So if we scroll down, you can see reduced JavaScript execution time, right? Just the JavaScript itself is taking a long time to execute, which makes sense since we had our 300 millisecond, blocking scripts that we're running. Really, the next two, though, I want to pay special attention to because these are directly impacted by what we're going to do with PartyTown. So the next one is minimize main thread work, which is exactly what PartyTown does, right? It takes work away from the main thread. And next one, reduce the impact of third-party code, right? By removing the third-party code, we should be able to affect, both of these items very significantly. All right. So don't take my word for it. Let's actually see what that looks like after we use PartyTown. Okay. So I'm going to head back over to my code base, still in that layout, the root layout component here, and now we'll enable PartyTown. So you can see I had previously commented out this PartyTown import, so I'll restore that. Likewise, there's this PartyTown component here that we have to render, as well as some attributes that we have to add. So we have to add type equals text PartyTown to every one of these scripts. There we go. All right. And don't worry about those steps that I just mentioned, because we'll cover those in the how to implement section of this video. For now, just understand that I'm enabling PartyTown. All right. So you can see that now out of our 4 scripts, each one has a type equals text PartyTown, 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 and the bottom one, the second to last, PartyTown and PartyTown. So all 4 of these scripts, because we're setting it to type text equals PartyTown, we're telling PartyTown that we want it to handle loading the script in a separate web worker. All right, so I'll save my changes to this file, I'm going to kill my local development server and just rerun that to start everything fresh. Likewise, in the browser, I'll just do a Command Shift R to just do a hard reload here to reset everything. And I'll close our old audit. And now let's take a look at where things stand with PartyTown. So let's head over to the Sources tab. You can see this time we have a lot less work being done by the main thread here. So if we look at top, you can see it's still taking care of our custom application code, but that's it, right? The few, like this intercom thing that you see here, that's just because intercom is injecting some markup into the page. So that needs to be here. But as far as all the scripts that are being downloaded, parsed, executed, and so on, they're not here anymore, right? They're no longer being handled by top, by the main thread. Instead, to find those, we have to look down in this PartyTown web worker, and the gears icon here is, representative of a web worker. So if I expand this, you can see, in the separate thread, it's loading from JS Deliver, the fake ad script, the slow script. There's the intercom chat widget is being loaded here. Google Tag Manager is being loaded here, right? All of this work now is being done separately in the separate thread in this PartyTown web worker. So that's all well and good, but how does it impact performance, right? Is probably what you're asking yourself. So let's find out next. So we'll do the same thing. We'll head to Lighthouse, and I'll kick off our performance audit, and we'll see how we do. All right, so the audit has finished, and you can see here just a drastic improvement, right? I'm seeing a score of 98% here, or 98 out of 100, all right? If we scroll down to our list, you can see total blocking time is down from 2.5 seconds, down significantly. And then down in the diagnostics list, you can see that the two items we saw before related to reducing or minimizing main thread work and the impact of third-party scripts, they're just removed altogether, right? They're not even problems reported on this list at all anymore. And that's just due to what we did using PartyTown. So at this point, again, I'll just reiterate that you have to keep in mind the same exact amount of work is being done in both cases, right? If we're just telling the main thread to do everything, same application code, same third-party scripts, we didn't optimize anything, right? It's just the same code is being run in that scenario compared to with PartyTown implemented and a separate thread handling third-party scripts, doing the same exact amount of work, but just doing it in a more optimal way. We get this kind of a performance difference, right? We're able to score 98 this way. All right, so we've seen the impact that PartyTown can have. So in this section of the video, I'll show you how to implement PartyTown in your Next.js application. So you can see here that I'm back on the PartyTown website, and I just want to point out that on this site, they do have integrations listed in the sidebar. If you click through to Next.js, they have some instructions here, but there's a caveat that this only works with the pages router. The worker strategy is not supported with the app directory at this point. And if you scroll down a bit, it says below are the instructions if you're not using the experimental worker strategy, which again only works with the pages router. So if you're using app router, like a new Next.js app, really, this is all you get in the way of guidance. In addition to the React guide. So you have this specific to Next.js, but also if you go to the React page, some of this, content you'd have to use in conjunction with that, right? So you can find what you need with enough searching and combining some of the scripts they give you. I'm going to walk through this in a more straightforward way as well instead. All right, so I'll head back to my article that I've been referencing in this video. Specifically, we're going to go to the Implementing PartyTown in a Next.js App Router project, this section, to see the steps. And again, this is all linked in the video description. So it says you can follow the steps below to implement PartyTown in your own Next.js App Router projects. And let's see. Yeah, I do have a disclaimer here just to read the PartyTown trade-offs page here, just to make sure you're good with using this in a production environment. So I would just read that, some of the kind of nuances there that come with working with PartyTown. If you've done that though, and you want to go ahead and offload third-party scripts using PartyTown, this is how you do it. So first step would be install PartyTown with this npm install command or pnpm or whatever else you use to install packages for your project. Next, you need to add a command to copy the PartyTown scripts. So in your package.json file, you need it in the scripts block. You need to add a new script that says PartyTown and that does this. So it calls the PartyTown command, copy lib, and then it copies the PartyTown files into the public directory of your Next.js project. And then inside of that, they're going to live inside of this tilde PartyTown directory. All right. So you can run this command by itself by running npm run PartyTown. So I'll just pause there and show you what that looks like in our demo application. You can see here if I head to package.json, there it is. There's the PartyTown script, and it does the same thing as I just mentioned. So if you run that, npm run PartyTown, that results in files being copied here. So if I go to public, here's tilde PartyTown. If I go inside of that, here are the files that PartyTown has copied over, right? And this is necessary because of how PartyTown works. It needs some publicly accessible JS files to do what it needs to, right? So that's why it copies these into your public directory so that they're accessible. So once you've added that, you can optionally also add this PartyTown command to the dev and or build scripts to copy PartyTown's files whenever the development server starts or the production app is built. Here's an example. So here's our same PartyTown script we had added, but now you can see we've updated dev and build so that it runs, the PartyTown command and then proceeds with calling either next dev or next build, right? Doing this just prevents somebody from forgetting, right? If somebody cloned down your repo and then just ran the command to start the development server, instead of them getting an error, having PartyTown not work because the files weren't copied to the public directory, it just happens automatically. So you can do that optionally if you want. You can kind of chain the commands like this to copy those files without anybody having to think about it. All right, once that's done, we'll move on to step 3. So it's to load the PartyTown component in your root layout. So this is a file we've been looking at so far, in this video the most. So at the top, we're going to import PartyTown from this package, just like that. Then we're going to render it inside of the head element like this. All right, so PartyTown and then forward equals data layer dot push. It's important to include this for PartyTown to work with third-party scripts that use this data layer convention. Like I think Google Analytics and Tag Manager are examples of projects that do that. So you can see here in the repo, if you clone it down, you can see I've added one extra thing actually. So instead of just adding this forward prop, I'm also setting debug to true, right? And I would recommend adding this in as you're initially setting up PartyTown, just to log, any errors that may occur, like while you're using PartyTown, while you're getting it configured, and then you can remove this, when you actually commit this code and go to production and so on. But yeah, probably a good idea to leave it on, while you're just testing PartyTown to get more verbose error logging and so on. So you can include that optionally if you'd like to. After you render that component, then it's time to enable PartyTown for specific scripts, right? So step 4 is to add type equals text PartyTown to scripts. So you can add that prop to the scripts you'd like to load via PartyTown. If you have a script you want to remain on the main thread instead, simply omit the type equals text PartyTown prop for that script, right? So for all our others, you can just go ahead and include it. So here's an example here, right? You can see we're loading some slow script from a third party, type equals text PartyTown. And we've seen that already, right? That would be this example here at the end of my scripts, just that prop that I'm passing into the script component. So after you've updated your scripts to have that, then the final root layout would look something like this, right? So you can reference this code block here or otherwise the example repo. You can see that in both places. So after implementing this, open Chrome DevTools and check the Sources tab. You'll see that the third-party scripts now load in a web worker rather than under the main top frame. confirming that PartyTown is working, just as we did in our tests, right? So just as we saw in our demo application, you can go ahead and open up DevTools and then see, that web worker called PartyTown to confirm that it's working, as well as run a Lighthouse audit and see what impact this has for performance. So that's about it for this video on working with PartyTown. If you encounter the issues that I have in the past where you have necessary third-party scripts, that are really needed for the site, but they're kind of, clogging up the main thread, causing performance issues, give PartyTown a look. It's a very cool, innovative project and a way to alleviate that issue. Thanks so much for watching, and happy coding.